The term, Basic 6 Instrument, typically refers to a set of 6 essential flight instruments found in most general aviation aircraft. These instruments are crucial for maintaining control and situational awareness during flight. The basic 6 instruments include: Airspeed Indicator. This instrument displays the aircraft speed through the air, measured in knots, nautical miles per hour. Attitude Indicator, Artificial Horizon. The attitude indicator shows the aircraft's pitch, nose up or down, and roll, bank angle, relative to the horizon, helping the pilot maintain level flight and control the aircraft's attitude. Altimeter. The altimeter provides the aircraft's altitude above sea level, usually measured in feet. It allows the pilot to determine the aircraft's height above the ground or the elevation of various landmarks. Vertical Speed Indicator. The Vertical Speed Indicator, VSI, shows the rate of climb or descent of the aircraft in feet per minute. It helps the pilot maintain a desired vertical speed during ascent or descent. Heading Indicator, Directional Gyro. The heading indicator displays the aircraft's heading or direction of flight, using a rotating compass card. It allows the pilot to maintain a specific course by indicating any deviations from the desired heading. Turn Coordinator. The turn coordinator indicates the rate and direction of the aircraft's turn. It combines the indications of the aircraft's roll and yaw movements, providing the pilot with information on the aircraft's coordinated turns. These instruments, collectively known as the Basic 6, are essential for safe flight in various weather conditions and help pilots maintain control and situational awareness in the absence of electronic navigation aids. Working of Altimeter. The altimeter is an instrument used in aviation to measure an aircraft's altitude above sea level. It provides pilots with crucial information about their vertical position in the atmosphere. The working principle of an altimeter can be summarized as follows. Barometric pressure. The altimeter relies on changes in barometric pressure as the aircraft ascends or descends through the atmosphere. The atmosphere's pressure decreases with increasing altitude, and this relationship forms the basis for the altimeter's operation. Setting the reference. Before takeoff, the altimeter is set to a known reference point, typically the current local barometric pressure at sea level. This setting is obtained from weather reports, air traffic control, or other reliable sources. Pressure measurement. Inside the altimeter, there is a sealed aneroid capsule or stack of thin metal diaphragms. As the aircraft changes altitude, the air pressure acting on the aneroid capsule also changes. Aneroid capsule. The aneroid capsule expands or contracts in response to the pressure changes. When the pressure decreases with an increase in altitude, the capsule contracts, and vice versa. The capsule's movement is mechanically transmitted to the altimeter's dial. Indicator dial. The altimeter dial is marked with altitude increments, typically in feet or meters. The mechanical linkage between the aneroid capsule and the dial causes the dial's needle or digital display to move accordingly, indicating the current altitude. Calibration and corrections. To ensure accuracy, altimeters need periodic calibration. Pilots rely on altimeter settings provided by air traffic control or from navigational aids at certain altitudes known as altimeter checkpoints. These settings allow pilots to adjust their altimeters for changes in atmospheric pressure and maintain accurate altitude readings. It's important to note that altimeters measure altitude above a fixed reference point, sea level, so changes in local atmospheric pressure due to weather systems can affect their accuracy. To account for these variations, pilots regularly update their altimeter settings during flight based on the current barometric pressure information provided by air traffic control or regional altimeter settings.